Okay, this is the second video for the lesson on solving radical equations. But to be able to do the second part, you need to be able to square binomials. And when you square a binomial, this is not x squared plus 49. Squaring means you multiply something by itself. So this is really x minus 7 times x minus 7. So if we square that, we have to FOIL it and take x times x, which is x squared. And we get minus 7x minus 7x, and then plus 49. But before we can finish, we need to combine like terms. So we get 7x squared minus 14x plus 49. And there is our answer. All right, let's try this again with a radical. This really means the square root of x plus 4 times the square root of x plus 4. So first thing, we need to multiply. Square root of x times x is x. Square root of x times 4 is 4 square root x. Over here, we're getting 4 square root x. And then over here, we get 16. All right, combine like terms. We have x plus 8 square root x plus 16. And there's our answer. Okay, we can do the same thing. 2 and 3 are just the same. Let me do 4. So you can see this one as well. Square root of 2x times square root of 2x is 2x. Square root of 2x times negative 6 is negative 6 square root 2x. Here we get negative 6 square root 2x. And here we get positive 36. Combine like terms. So we have 2x minus 12 equals the square root of 2x plus 36. And there's our answer. This radical in the middle does not simplify because you don't have any pairs or groups in a 2 or an x. Okay, let's go back to solving equations. We need to keep that skill. We'll use it in a minute. On the first one, this is one of our old ones. We need to isolate the radical. So we're going to subtract 3 from both sides. So we have the square root of x minus 2 equals 2. Now we can square both sides. So we get x minus 2 equals 4. Add 2 to both sides. So x equals 6. And we were able to solve it like that because it's a linear equation. So we put the x's on one side and the variables on the other, and then we're done. I said that wrong. The x's on one side and the numbers on the other, and then we're good to go. Now, number 2, we haven't done one like it, but number 2 is a cube root. And to undo a cube root, instead of squaring it, we have to cube it. So on here, we get x minus 1, and here 2 cubed is 8. So we add 1 to both sides, so we get x equals 9. On the next one, we had one like this last time too. We're going to square both sides. And here we get 7x plus 8. And over here we get x squared. Now this one is different than the other two because the other ones were linear. So we got the variables on one side, the numbers on other. This is quadratic. So we have to set it equal to 0. And I want my x squared to stay positive. So since it's positive, I'm not going to move it. And I'm going to move everything else. So now when I factor, my two numbers that multiply to negative 8 and add to 7 would be negative 8 and 1. So x equals 8 and negative 1. But now we need to check. When it gets plugged in the radical, it's going to work out okay. The issue is we can't have a radical equaling a negative number. So if I put in 8, it's fine. But if I put in negative 1, that is not going to work because the radical can't equal a negative. So therefore, it is extraneous. Sorry, my screen keeps jumping. Doesn't make it easy to watch. All right, now let's look at number 4. 4 is a little different because you don't just have an x, you have an x minus 4. But since we reviewed squaring binomials, we should be just fine. So we're going to square both sides. So this side is just 3x minus 2. But here, when we square a binomial, it's x minus 4 times x minus 4. So here we get 3x minus 2. And then we got to FOIL or distribute. X squared minus 4x plus 16. Always a good idea to combine like terms. Okay. This equation is x has the x squared, so it's quadratic. So we're going to have to set it equal to 0. So I'm going to subtract 3x from both sides and add 2 to both sides. So I get 0 equals x squared minus 11x plus 18. So when I factor it, my two numbers are going to be -9 and -2. So when I solve, x equals 9 and 2. Now, you're not going to have to write out this much work each time to check it, but I want you to have a mental picture of what you're looking at because I think this will help some of you. We're not worried about checking the square root part, but the square root can't equal a negative. So if I plug in 9 for x, I have 9 minus 4. Well, 9 minus 4 is 5. That's positive. That's good. If I check the other one, I put in a 2 for x. I have 2 minus 4, which gives me -2. A radical for these problems can't equal a negative, so it doesn't work. So this one becomes extraneous and 9 works. So you're not throwing out the answer because you're negative. You're throwing out the answer because when you plug it in, it makes the radical equal a negative. And that's the difference between the two. Okay, let's look at number 2. On number 2, we want to square both sides. So over here, I'm going to get x plus 2 times x plus 2. Over here, the radical cancels and I just get x plus 2. So now I need to FOIL or distribute. So I get x squared plus 2x plus 2x plus 4. Always want to combine like terms. Now we stop and look. It's a quadratic equation, and because it's quadratic, we need to set it equal to 0, and we want to keep the x squared positive. The x squared positive is where it is, so we're not going to move it. We're going to leave it there and subtract x from both sides and subtract 2. Leave me with x squared plus 3x plus 2 equals 0. Okay, now we're going to factor that. The two numbers that multiply to 2 and add to 3 would be 2 and 1. So we solve x equals -2 and -1. Now let's think about the check for a second. For the check, we're not concerned about the radical. That will work itself out. But on the other side, if I put in -2, I have -2 plus 2, which is 0. But is 0 a negative number? No, that's okay. On the other one, here I'm going to get -1 plus 2, which is 1. Is 1 a negative number? No, it's good. So both of them work. Okay, I want you to pause the video, and then I want you to try number 6 on your own. Okay, if you tried number 6 on your own, you would square both sides, combine like terms, set equal to 0, and factor. And when you factor, you get -5 and -6. And when you plug them in, both give you a positive answer. So both work. All right, the last type. Oh, side note. These three and the one before it, we check the answers for extraneous solutions because we factor. If we don't factor, we don't need to check. So let's see what happens over here. On these, we have two radicals. And when we have two radicals, we need to keep it on the opposite side of the equal sign, which they are in number 7. So I'm just going to square both sides like this. So here I get x plus 3. Here I have to write it, I have to write it out twice, just like I squared every other binomial and just like we did at the beginning of this video. So this gives me x plus 3. Square root of x times square root of x is x. Then I have -3 square root x. Over here, -3 square root x. And then plus 9. Now, I definitely want to combine like terms. But something else we might point out, when we have an equation and we have the exact same thing on both sides, they cancel out. So on this one, the x's cancel out. So when I simplify this, I get 3 equals -6 square root x plus 9. Now we still have a radical, but it's much simpler than it was. So we need to solve this equation and get that radical by itself. Now some people get stumped, but think if you had the equation 3 equals -6x plus 9. Well, most of you could probably tell me we have to subtract 9 first, and we would get this. Well, that's exactly what we're going to do over here. We're going to subtract 9 first and get -6 equals -6 square root x. Well, then if we go back over this equation in black to get x by itself, we know we got to divide by -6. All right, so let's do the same thing over here. So we get 1 equals the square root of x. Okay, now that the radical is by itself, now we can square it again. So I'm going to square both sides. The square root of x squared is x, and 1 squared is 1, and there's my answer. Okay, we got 2 more left, but I'm just going to do 1 more, and I think that'll be enough to kind of get you through. 8 and 9 are very, very similar. The thing is that both radicals are on the same side, and you don't want to start squaring with both radicals on the same side. The one you want to move is the one that's simpler. So we're just going to do the square root of x. So when I do that, I get the square root of x plus 6 equals the square root of x plus 2. Now I can square both sides. So this gives me x plus 6. And this, remember, you've got to write it out twice. The left stays x plus 6. On the right, square root times square root is x. And we get plus 2 square root x, plus 2 square root x, and then plus 4. So we want to look for like terms to combine, but also notice the x's cancel out again. And we do, we get 6 equals 4 square root x plus 4. All right, now we want to get the radical by itself. So to do that, I'm going to subtract 4 from both sides. That leaves me with 2 equals 4 square root x. So to get the radical by itself, now I'm going to divide by 4. Over here, you can see you get the square root of x. 2 fourths is not 2. 2 fourths is 1/2. Now, to get rid of the radical, now at the last step, we can square again. Here, when you square the radical, you get x. Here, when you square a fraction, you square the top and square the bottom. 1 squared is 1, 2 squared is 4, and that is your answer. Now on 7 and 8, and then again on 9, on those, you don't factor. And if you don't factor, then you don't need to check for extraneous solutions. You only need to look for them when you're factoring. Okay, 9 works the exact same. You're going to add that radical over, square both sides, and go from there.